Hey kids! All right, this lesson 5 is super involved. There's a lot going on, so let's jump right in. In the objective, it says we're going to use multiplication to connect volume used as packing and filling. So we're going to be filling a lot of tanks with water and also connecting it to the packing with the cubes like we did before. But we're going to learn something really interesting about centimeters cubed and also talk about liquid volume, which is liters and milliliters. So they have a little warm up, and this is just finding the area. And remember, the area is length times width. And so if they give you a rectangular shape with different dimensions, you just multiply those to get the area, label in units squared. If they give you a square, the attributes of a square are that it has 4 sides the same size. You can assume that the other dimension is going to be the same one as listed, and you multiply and get that. Then for a little warm-up problem, solve what this is. The area of the base, 4 times 5, that's your length times width, times the height. There you go. Volume in centimeters cubed. Don't forget 3 dimensions, 1, 2, 3. So then we have what we're going to see a little bit more of today. Figures with multiple faces saying, well, what is the area of this face? What is the area of this face? What are if the measurements here are 3 and 3, then for C, which is the same as the top and the bottom, then what would be the area of that face? Well, that's going to be the 3 times 3 for 9. What if you use face B and it's a 3 by 8? That would be 24 centimeters squared. How about face A? I don't know why I'm doing it backwards. Who cares? It's a little bit more fun this way. If you use A, it's going to be a 3 by 8. So just kind of a little bit of practice. Now there's a little something extra here before we get on to the next part. And it's, again, if they give you the area of a face, hooray, they've already solved for the length times the width. So go with it. Take that. You only now have to multiply by the height or the other dimension they didn't use in the length and the width. Look at which face is being used for the area and find the dimension that goes out from that one. Okay, so there's your volume. Now, in this next tank, it's gonna take us into the next part of this video, which I'm gonna unhook you and we're gonna go for a little walk briefly. But we have a tank, okay? So how many milliliters of water are in the tank when full? Well, we're going to have to investigate because this is measured in centimeters. And if they're asking about liters, well, what do we do with that? So there are 2 activities today that require like extra stuff. And if you're in my homeroom class, I'm going to hopefully have you covered. If you're not in my homeroom class, then you can just kind of watch and learn. First of all, we have 2 boxes that I'm going to show you on a table, and they're labeled, and you have to figure out what the volume is, how many cubes are packed, what's the length, width, and height, and what's the total volume. Okay, now, using the same boxes from problem 1, record the amount of liquid that your box can hold after we investigate this next piece of information. So, let's take a little walk. Okay, I won't turn this off. Okay, so we have 2 prisms here, rectangular prisms. So take a look. You need to calculate the volume. There's prism 1 and prism 2. Okay, look at the length, look at the width, look at the height. You can pause the video while you record these measurements. Okay, now the next thing we're going to look at is this graduated cylinder. Okay, now the graduated cylinder is a tool that we use to measure liquid volume. In the book, in the workbook, it has a graduated cylinder that's a little thinner and smaller than mine. Mine has 100 milliliters. Okay, you can see the top, 100, but I've got it marked at 50. Okay, so if you can see right there, it's right at 50. Okay, focus. Okay, so it's right at 50. So what they want us to do is watch. There you go. I'm going to hold it right there because I am going to add 1 milliliter of pre-measured water that's in my little dropper that I need to show you that has 1 milliliter. Okay, and so I think I still have a drop left, a couple drops left. So now I should have 51, which I do. You can see it's right at the line there. Okay, so 51. Now the next thing that I'm going to do might astound you. I'm going to take this cube, okay, and I'm going to put it in the water. I want you to see what happens. Okay, now the water level just went up, and this is going to focus here in a second. And gosh, it went up exactly 1 milliliter. So notice that 1 cubic centimeter is equal to 1 milliliter. So that is something that you are now expected to know as we proceed with this math lesson. Okay, so it's really an important relationship, and so you need to write that down. 1 centimeter cubed, 1 cubic centimeter is equal, very important symbol, it's equal to 1 milliliter of liquid. It's a very important relationship. You're going to have a whole bunch of questions about this year. Okay, so back to the question. If you want to know how many milliliters of water are in the tank when it's full, you then need to calculate the volume of this rectangular prism in centimeters cubed, and that is equal to how many milliliters for your final answer that it's equivalent. Then to change it to liters, remember that liters are 1,000 times greater than milliliters. Use your King Henry place value chart to recognize that milli is way down there in the thousandths place and liters are in the ones place. So it's 3 place value positions away. So do the calculating. 30 times 20 times 40. I like to take only the numbers that have value and put the zeros just at the end. So 3 times 2 times 4, and that's 6 times 4, which is 24. And then each zero, ones place here, ones place here, ones place here. So ones, tens, hundreds, and then you get 24,000 centimeters cubed. Okay, now that's equal to 24,000 milliliters. We just proved it using the graduated cylinder. And so what do you do now? Well, you have to take your 24,000 and divide it by 1,000. Because we need to show this amount in liters. So that's the whole warm-up, and that will put you down, all the way down here. So this is the box number 1. Box number 2, you have to figure out the length, width, and height and volume of those that I put up there. And then to show the water in the beaker. Now everybody's homeroom teacher is going to have a different amount if they choose to do this activity. But at first in my class, we had 50 milliliters. And so you would shade this much of the beaker, okay? Now, it was at 50, okay? And for ours, this one says 5, mine's 50. After 1 milliliter of water was added, we had 51. So you barely go above that. That's probably too high, but oh well, just slightly higher. And then after the 1 centimeter cube was added, then we had 52. And so the important thing to note is that 1 centimeter cubed is equal to 1 milliliter. And that's really what you need to know on this. So sorry if that was off the screen. So 50, 51, and 52. Okay, 51 milliliters and 52. All right, and there's more. There's a lot more. So what conclusion can you draw about the 1 cubic centimeter and the 1 milliliter? Well, we kind of already wrote it on the previous page, but basically what you can say is they both took up 1 milliliter of volume in the beaker. Or if you want to call it a graduated cylinder. Cylinder. There you go. And so here's where your 1 centimeter cubed is equal to 1 milliliter, and you're proving it there. Okay, now as we zip right along, we're going to slow down here because these are going to get really a lot tech heavy, lots of calculating, lots of drawing. Have patience. The tank, shaped like a rectangular prism, is filled to the top with water. Okay? Will the graduated cylinder hold all the water in the tank? If it will, and it has 1 liter, then how much more will the beaker hold? But if it doesn't, how much more will the tank hold than the beaker? And explain how you know. So we need to find this volume, okay? And since we're using centimeters, which we know are equivalent to milliliters, why don't you just write the equivalent right here? Because 1 liter is equal to 1,000 milliliters. So write that right away. And we know that in order to get our volume for the tank, we need to do length times width times height. So take your 3 dimensions. It doesn't matter the order. You can do them in any order. But I'm going to take the 13 times 10 first and get 130 before I multiply by 8. Okay. And then if you have to take this out and multiply it out, 3 times 8 is 24. 8 times 1 is 8 plus 2 is 10. It's not 104. You also have to calculate that extra 0. So it's 1,040. And our units, don't forget, centimeters cubed. So the tank holds 1,040 centimeters cubed, or milliliters, which we know it's equal, okay? So the tank is going to hold this much water. So if I pour everything into this beaker, will the beaker or graduated cylinder hold all of this? And you might be saying, no, you're going to spill it. So how much more will the beaker hold, or how much more will the tank hold? So now we need to just do a simple calculation and find the difference between the two. And since we're using milliliters, which are interchangeable in this problem, it's going to be 40 milliliters more in the tank. So the tank holds 1,040, which is 40 milliliters more than the graduated cylinder. Okay. Okay. And then we're going to go ahead and move forward. All right. A rectangular fish tank measures 26 centimeters by 20 centimeters by 18. Length, width, height. The tank is filled with water to a depth of 15 centimeters. Okay, now you can draw this. It can help you kind of see what's happening. What's the volume of the water in milliliters? Let's do our 26 by, hold on, finish this out. It's going to be 3-dimensional, by 20. getting in there, by 18. Label your units. Okay, now that's the size of it, but it's only filled up to a depth of 15. Okay, so here's your water. Okay, there you go. So you take your 18 and you go, well, we got to break this into parts. Okay, 18 is made up of 15, plus what? So for right now, we just need to know the volume of water. So we're going to use our 26 times 20 times 15. Okay, and that will give us our volume in centimeters, but also milliliters. So 26 times 20, they don't really give you a whole lot of room here. Put the 0, 1 on the bottom so that you don't have to have a whole row of partial products. 0 times everything is 0. Now move on. 2 times 6 is 12. 2 times 2 is 4 plus 1 is 5. So it's 520 just for those two, but you need to continue. Times 15, that's the third dimension. 5 times 0 is 0. 5 times 2 is 10. 25, 26. Then 0 here. But 0 here, 1 times 0 is 0. 1 times 2 is 2. 1 times 5 is 5. And so you end up with 7,800 centimeters cubed of water. Okay, which is also 7,800 milliliters. We know it's equal of water. Okay, but how many liters is that? So I'm going to take my 78. Turn this. 7,800. Now it's a little bigger for you. 7,800 milliliters equals how many liters? And remember that it's a 1,000 milliliters to 1 liter. And so you're going to divide by 1,000. And then you go 1, 2, 3 with the decimal. So you end up with 7.8 liters. Okay, now that's this one. So what's the volume of the water in milliliters? 7,800 milliliters of water here. And then how many liters is that? Okay. And you know what? We're not going to cube that. That's already, sorry, I was thinking centimeters. Okay. So how many more milliliters of water will be needed to fill the tank to the top? Well, now we have to think about what is that other measurement. Now we need that 3. So we only need the 3. We're done with the 15, but we still have to use the 26 times 20 times the 3 in order to get the volume of the airspace at the top. Okay, so this is the explanation. I have to find the volume of airspace at the top in order to fill it. Now, I already found out 26 times 20 up here, and I got 520. So I need to do that times 3 in order to find the volume. Let's do it over here. 3 times 0 is 0, 3 times 2 is 6, 3 times 5 is 15. There's your 1560. And what unit are we using? It says how many more milliliters, so we can use milliliters for the whole thing. And so 1,560 milliliters of water needed. Okay, and that's just to fill up the airspace at the top. Okay. Final question. I have to tip this even more. A rectangular container is 25 centimeters long and 20 centimeters wide. If it holds 1 liter of water when full, what is its height? If volume equals length times width times height. And we have the length and width, which are 25. Sorry, see a little blonde hair there. 25 times 20 times mystery number equals 1 liter, which is also 1,000 milliliters. Just put the 1,000 milliliters. 1 liter equals 1,000 milliliters. Put that off to the side to show that you know what it is. Okay. And then we have to figure out what this is, and then we're going to divide that. Okay. So basically 25 times 2 is 50 plus this extra 0. So 25 times 20 is 500. So I have these 500 milliliters, and I know that that is a portion of this. And so what we end up doing is we're going to take the 1,000 and we're going to divide it by 500 in order to get 2. And that would be the height of the rectangular container. Okay, gosh, it's squeezed in there. It just does not fit very well on this table. Okay, so that's a lot of information. It's kind of a tough lesson, but I hope this video was informative. If you liked it, click subscribe. And if you're in my class, haha, you're stuck with me till the end of the year. I'll see you guys on the next video. Bye now.